let's do one more example, and then while I'm writing it, I will tell you my point on that. The integral of e to the 7 from e to the 7 e to the 9 1 over x square root ln x dx. One more example on the substitution rule. That's one. Those questions, I can show you millions of them, but it's not going to make you good at doing them. So when it comes to integrating, you have to go home and integrate. So I like to comparing it with push-ups. I can show you how to do push-ups many times. Does it make you good at push-ups? No. So we'll show you the idea. We show you some tricky parts of it, and then you go home and do it yourself many, many times. So it makes sense. If you compare it with exercising, that's why homework called exercise 1, exercise 2. So you see this integral in front of you, and then as last time, we need to figure out what to choose u. Too many options in this case. I see 1 over x can be u. Last time I told you denominator, let's make denominator easier. So x squared root log x to be u can be done that. Square root of log, oh, we don't like that. We can make that to be u. Just log everything. So too many options. And usually when I was learning this, you choose something and it doesn't work. You choose another one and it doesn't work. And then you want to call your friend. And my phone is connected to the wall. And the line for the internet and the phone is the same line. So you have to you have to ask your older brother to stop playing the game. And that's very hard. He's fighting back. Then you get the phone. Then you call your friend. And she lives far. And then she also stuck. So we both stuck now. And that's it. And there is no internet. And then the library is 1 hour away. And that's how I did it. That's how I did all my undergraduate and graduate degree in math. Pure math. Proofs and everything. You do integral for 3 pages. And it was all wrong after all. And you don't know until you go to class and compare with others. So I'm just complaining about this. Now, let's just do it and see if it works. And if not, you post it in the forum and you get the help. How amazing is that? I'm very envy that that's how amazing it is. What do you think we should choose u? ln x? ln x. But why? Why you guys don't think it's like 1 over x? I don't like that too. Why do you think ln x is a good choice?
Because the derivative is 1 over x.
Yeah, more answers, yeah?
Because that way 1 over x could be eliminated. Not eliminated, but it could be
substituted, which is chapter topic. Very good. ln x derivative gives you 1 over x. So the hint was to undo chain rule, we use substitution rule, which mostly means one part of the integral looks like a derivative of another part. And we know that derivative of log is 1 over x, and I see 1 over x over there. So let's try that, u. So the idea is I can rewrite it. It's not like I'm changing anything. I'm going to relocate some stuff. 1 over the square root of log times 1 over x dx. Now it's even more visual. I just relocated things. Now it's even more visual. If u is ln, then du is perfectly 1 over x dx. Does that make sense? And another hint I gave you last time. If square root has function in it, usually that's a good choice for u. We don't like square root of hard stuff. So that also matches here. ln is inside of the square root. Let's write down the table. If u is ln, du is 1 over x dx. We need to change limits of integration. If I keep them the same, they will not match the variable. You can keep them using way 2, I showed last time, which is here's notation. But I will stick mostly to the official book version, and it's American way of teaching it. You always have to change limits of integration, so I will be doing that. In Calc 3, you will be not changing them at all. You will see it's so much easier when you just keep them as they are. So, but it's not very hard in this case. X used to be e to the 7. Well, u is ln of x. ln of e to the 7 is 7. ln and thus e. Those are inverse functions. X used to be e to the 9. Then u will be 9. So it's very nice. It actually was pretty fast. This is my extended table for u substitution. After that, I put equal sign, bless you. Integral from 7 to 9, 1 over square root of u du. The tail perfectly matched with du. 1 over x dx is my tail, not mine, the integral tail. It perfectly matched with du. Does that make sense? Can you do this on the test? It's a classical example from the exam. Put it in the little circle or a star. We like to put this example in the exam, and by we, this year I actually mean me, because I'm creating exams this year. I'm a coordinator of this course. So this is a very classical example to put in the multiple choice question. Equals. How do you integrate 1 over square root of u? Who knows? Who remembers? Remember, if you yell out loud the answers, it helps you not to fall asleep. So it's very good, especially people at the back. People at the back might feel sleepy. If you do, you should sit in front. I'm yelling so much, it's hard to feel sleepy. Wait, anyone else? How do you integrate 1 over square root of u? No, you already been to. Anyone new? Let's see. Yes, let's.
You can turn it into x to the negative 1/2.
U today, negative 1/2.
Yes.
Very good, very good.
That would probably make it a little easier on the eyes.
And now, tell me what's the answer?
It would be u to the 1/2 divided by 1/2.
Amazing. U to the 1/2 divided by 1/2. Because it's a power rule, we add 1. Bar 7, 9. And before continue, we have to check if 7, 9 are actually your u or ux. And we don't go back to the original variable. Why would you do that? If 7 and 9 already match the variable, it is u. So we don't have to go back to x. If you go back to x, you have to go back your limits integration to x as well. And that's you undoing your own work when you change limits of integration. So that's the whole point. We don't go back when it comes to definite integral if you change limits of integration. 2u to the 1/2, 2, 9 to the 1/2, minus 2, 7 to the 1/2. Ask me, how did I get 2? Do you know where the 2 came from? Reciprocal. We divided by 1/2, that means multiply by 2. What is 9 to the 1/2? 3 times 2? 6 square root of 7. That is the answer. What do you think about this? Can you do this? Is it doable? So, interesting point to mention. I like to point out about substitution. Substitution. Again, we call it use substitution, but it can be any letter. I like my favorite example is if you choose letter J, that's J, B, ln x. Do you know why I like it? Because it's the first letter of my name. And then I like it DJ. DJ is 1 over x. Like, come on, this is the best thing ever, right? So you can be creative. You will see in the scientific articles where people use O. I hated it so much. O do. Do you know how ugly it looks? Integral of O squared do. What is this? So I criticize it gently as a graduate student in class. And unfortunately, the author of the article was a tenure professor in the room. And then he mentioned later, Julia, I heard you did not like my O's in the article. And I was very young. And I was like, yeah, I didn't. I don't know. I always was very straightforward about things. So like, it's a bad Ukrainian habit. Nah, I didn't. Why would you choose O out of the whole alphabet? You can do U1, U2, U3, W, anything. But O? No, it's horrible. And he's like, My point is substitution is a transformation. Transformation. And by that, I will show you some little neat idea. We worked with x and f of x. And we were looking below the graph of the function f of x equals 1 over x square root of ln x. This is the function that was inside of the integral called integrand. So let me show you again. This is the function. From calculus 1, you maybe remember area below the graph, approximation with stupid rectangles. So we're going to do it again soon. But that's one of the applications. We found the answer, 6 minus 2 squared root of 7. That's some kind of number. It's something like 3 point blah, blah, blah. So this 3 point blah, blah, blah is the area from e to the 7 to e to the 9 below this graph of the function. So this is the area we found. Does that make sense? Well, the idea of substitution is we did not like the function. It was hard to integrate, and I did not want to do rectangles or numerical analysis in general. I still believed we can do it exactly. Remember, rectangles and other methods gives you approximate answer. Nothing is better than exact answer. So we used the transformation, which we call the substitution method. And we switched from the variable x to the variable u. And the function now became out of u. Out of u. So the graph is a bit different. It's more or less the same because of the 1 over the square root. So the function f of u now looks like 1 over, what was it? Square root of u, right? And now we were looking at the limits from 7 till 9. And this is the area. You see it's a bit taller. The cool part is the area is exactly the same. It's just shaped differently, but it's the same. The number is the same. The answer is the same. And it happened because we used a transformation called u equals ln x. And it can go back and forth. And that transformation will help us to integrate easier. So it's a very interesting idea. Transformation. And the idea is, that's why you have to change limits of integration, because variable x equals e to the 9 and x equals to the e to the 7 is not the same thing as u equals 7 and u equals 9. You have to change limits because the shape changed, the shape of the graph changed. So you have to shrink or stretch from where and to where you're looking the area. A cool example is, I like to show a water bottle. So I have some water left here, and it doesn't have any marks. I don't know how much water is this left. Also, it has lemon in it. That's why it looks so weird. It's not yellow. So this is the integral. So remember, if it's area below the graph, and I mentioned already, we're going to learn volumes in this class. Double integral gives you volumes. We're not going to do double integral in this class. We can do it next one. But we will do volumes. Okay, the volume of this water can be found through integration. But I don't want to, it's complicated. I don't know how to do it. The easier way is to take this water and pour it into a measuring cup. So this is the idea of the measuring cup. I would even say that U substitution, or whatever letter you chose, is the measuring cup. It helps you to take the same amount of water, put it in another place, and know the answer. It's 6 minus 2 squared root of 7. So we're using some tool to find something, and that is a transformation. From this shape, it will go into measuring cup, and maybe it will be so much wider. Does it make sense? How cool is that? But the measuring cup will be wider, so the limits of integration change from 7 till 9 versus e to the 7 and e to the 9. So all of those ideas are pretty fascinating. That's supposed to help you to remember that, A, change limits of integration unless you know how to cleverly keep them, like so. And if you do change, don't go back to the original variable. Why would you pour it into measuring cup and then pour it back? That doesn't make sense. So remember that. We're pouring water into measuring cup. That's definite integral via U substitution or just substitution. That is good. Do you have questions about this or comments? I feel like it's a pretty fascinating topic.